Hello guys, welcome to today's video. Today we are going to be looking at section 1, which is types and components of computer systems, and in today's video we'll be majoring on main components of computer systems. Let's get straight into it. And so in today's video we will learn the following. We'll learn about hardware, software, digital and analog data, and we'll look at some topical acronyms. Yes, topical acronyms are simply like acronyms which we find in the topic, like CPU, central processing unit. Yes, we're going to look at all of that in today's video. What is hardware? Hardware refers to the physical components that come together to make a computer system. For example, mouse, keyboard, monitor, printer, plotter, camera, and etc. So basically, hardware is the things we can see. Hardware is the physical components. We can see a mouse, we can feel a mouse, so in brackets it is a hardware device. So the physical components that come together to make a computer system, we term them as hardware. There are two types of hardware. We have internal hardware and external hardware. Internal hardware refers to the components inside the computer, such as the CPU, RAM, and motherboard, which perform processing and storage tasks, whilst external hardware include devices outside the computer, like monitors, keyboards, and printers, used for input, output, or peripheral functions. So the internal hardware, yes, they are hardware devices. As we said, hardware are physical components that come together to make a computer system. So there are ones that are inside the computer that we can't really see. So the ones that are inside the computer, they are termed as internal hardware, and examples include CPU, which means central processing unit, RAM, which means random access memory, a motherboard, and so many others. The external ones are the ones outside the computer, like monitors, keyboards, printers, and others used for various activities. The internal hardwares are usually used to perform processing and storage tasks, while the external hardware is used for input, output, or peripheral functions. Let's take a look at some of the examples of internal hardware. So starting with the motherboard. The motherboard is the main circuit board in a computer, connecting components like the CPU, RAM, and storage devices. It manages data flow through the chipset and provides expansion slots for add-ons like graphics card. Power and communication ports for peripherals such as USB and audio are also included. The BIOS and UEFI firmware on the motherboard initializes hardware during startup. It determines the system's compatibility and upgrade potential. So this is what a motherboard is. Let's look at the next internal hardware device, a graphics card. The graphics card, also known as GPU, that is graphics processing unit, is an internal hardware component responsible for rendering images and videos on a computer screen. This means that without a graphics card, you will not be able to see the images and videos that you can see on the computer screen and that you are using to watch this video. So it's all thanks to a graphics card you are able to see this video and see images on your computer screen. It also processes graphical data and offloads these tasks from the CPU, improving performance for gaming and media applications. So the better a graphics card is, the better your gaming experience. Those of my viewers who are into gaming. The graphics card connects to the motherboard via expansion slots like PCIe. We'll learn the meaning of PCIe in the topical acronyms. It has its own memory known as RAM to store graphical data for fast access. A powerful graphics card enhances the quality and speed of visual tasks such as video editing and gaming. This explains what I said earlier, that if you have a better graphics card, your gaming experience will be better and your video editing too will be better. Let's move on. We also have a sound card. A sound card is an internal hardware component that enables a computer to produce and manage audio. So we learned about graphics card that produces images. So sound card, of course, has to do with audio. It produces and manages any audio, including the voice we are hearing right now. It processes audio signals and converts digital data into sound that can be played through speakers or headphones. The sound card connects to the motherboard via expansion slots and may have its own memory for audio data. It supports various audio formats and provides input-output ports for microphones, speakers, and other audio devices. A good sound card improves sound quality and supports features like surround sound. So this is all about sound card. Let's move on. Now we are done with hardware. I hope you understand it. Let's move on to software. Software refers to the programs that control and manage the computer system and process data. Software falls into two categories: application and system software. Just as the hardware, we have internal and external hardware. For the software, we also have application and system software. And software are the programs that control and manage the computer system and process data. So without the software, the hardware will technically be nothing. I hope you understand that. Let's move on. So let's look into application software. Application software provides the services that the user requires to solve a given task. Examples: word processing, spreadsheets, database, video editing, graphic editing, audio editing, computer-aided design, etc. So these are some examples of application software. So in summary, the application software, they provide the platform that the user requires to solve a given problem. And these are some examples. Let's go to system software. System software is a software designed to provide a platform on which all other software can run. So system software, it is the software designed to provide a platform on which all other software can run. Examples: we have compilers, linkers, device drivers, operating systems, utilities, etc. Now we have learned about hardware and software. Let's move on to analog and digital data. Computers can only understand data in binary format, that is, a base 2 number system that is only 0 and 1 values. This is referred to as digital data. Digital data is therefore information that is represented in discrete values, typically as zeros and ones, making it easier to store and process. Digital data is more accurate and less affected by noise or interference compared to analog data. Analog data, on the other hand, is continuous data that represents real-world information, such as sound, light, or temperature, changing smoothly over time. It requires conversion to digital form for computer processing. Now let's look at how analog and digital data has to do with the components of the computer system. If analog data is being sent to a computer, it must first be converted into digital data using a hardware called analog to digital converter (ADC). If the computer is controlling a device, then the digital output from the computer is converted into analog form via a digital to analog converter. So to explain further, computers only understand digital data. So any type of data coming into the computer as analog must first be converted into digital data for the computer to understand. So it's the job of the analog to digital converter, which is the ADC, to convert this analog data from our voices, sound, video into digital data for the computer to understand and process. If the computer is also controlling a device, then the digital output from the computer must be converted into analog data for us to understand. And that is where the digital to analog converter comes in. Let's look at the following graphs. The graph on the left shows analog data, where an infinite numbers of values can exist. Examples: 2.5, 3.652, etc. The graph on the right shows digital data. Notice that only exact values of 1, 2, 3, etc. can be taken. So for analog data, a wide variety of values can exist, but for digital data, it is exact. And yeah, that is it. Okay, so we are done with the lesson. Let's look at some typical acronyms. We have DAC, which means digital analog converter. We have ADC, which means analog digital converter. We have the CPU, which means Central Processing Unit, CAD, which means Computer Aided Design, GPU, which means Graphics Processing Unit, RAM, which means Random Access Memory, USB for Universal Serial Bus, BIOS for Basic Input Output System, UEFI for Unified Extensible Firmware Interface, PCIe for Peripheral Component Interconnect Express, and RAM for Video Random Access Memory. That is all for today's lesson. If you enjoyed the video, I encourage you to subscribe so that you do not miss on the next lesson. Until then, I'll see you the next time. Bye.